today what we're going to speak about are how to use assembly mates inside of SolidWorks to capture real-world motion in your SolidWorks assemblies. So we're going to focus on a number of different areas of the software today. Beyond basic introductions, we're going to get into both advanced mates and mechanical mates to capture some of that real-world movement. And then towards the end of this presentation, I'm also going to touch on the SolidWorks animator to see how you can take the movement that you've since captured in your SolidWorks assembly and reuse it to create really nice and high-res animations of your assemblies that you can reuse beyond that. So the first part that we're going to focus on, or the first assembly that we're going to focus on this morning, is this 10-ton screw jack that you can see animating here. And we want to capture some of this similar motion that you're seeing on screen right now. We want to make sure that when we turn the input shaft of this jack, that the screw itself actually actuates appropriately based on the gear ratio between the worm and the worm gear on the inside of this assembly. Okay. So I've broken this down. I've split this up into two sections here. We're going to focus on advanced mates and mechanical mates. I was originally going to show these in order, but just given the reality of working with mates inside of SolidWorks, you know quite well if you've worked with SolidWorks assemblies before that you don't go through and add all of your coincident mates, for example, first, and then add your concentric mates after that. You simply add them as necessary and as you go along in your design. So it's going to be much the same here. We're going to focus on both advanced mates and mechanical mates inside of our 10-ton screw jack to create motion that you can see here in this short animation. All right, so we have that input shaft down towards the bottom, and we want to make sure that we capture the gear ratio between the worm and the worm gear, and then translate that into a translation mate between the worm gear and the screw. All right, so let's jump into our SolidWorks assembly and see how we can actually link this up. So we're looking at our 10-ton jack on screen right now, but if we section view this model here using our section view tool to just cut away the housing, you can see here one thing inside of section view that's really nice is down towards the bottom you have selected components, and you can select which components you want to section and which ones you want to leave alone. Okay, so right here all I've done is I've sectioned the model, the assembly, with the right plane and excluded everything but the housing. Okay, so that allows us to see inside very easily. Now I already have a few mates in this assembly already to capture, say, the concentric mate here between the screw and the housing, but you can see that I can very easily drag this in and out of the housing without regard for reality. So, this is very common in SolidWorks, and one of the things that we're going to touch on is how you can prevent this. So really, realistically, I want to be able to, when I, whittle this down to this end here, I want this to contact the housing and stop. I don't want it to go through the housing, which is a bit unrealistic to say the least. So all of that we're going to capture using SolidWorks mates. So the very first thing I'm going to do is I'm going to insert a few components into this assembly. The first of which being my my worm gear. So we'll insert some new components. We'll browse for that worm gear here and drop it in place. Now I've used some smart mates, or excuse me, mate references beforehand. So when I drop this in, I can easily snap to the screw itself. We'll just find a mate or a face that it can be concentric to somewhere in and around. Let me zoom in here and make it a little easier on myself. Right around here is pretty good. All right, so I can click to place this worm gear. You can see it's going to form an automatic concentric mate based on that mate reference, and I can just say OK. Okay, with that in place, you can see it stays concentric to our our screw, and now it's just a matter of mating this in place. Now what I can certainly do, if we go to, say, the, I think it's going to be the, the right view. If I go over to the right view here, we can see what I really want to do is I want to place this worm gear so that it's spaced evenly between these two faces here, or perhaps between the shaft of the worm, okay, which is maybe a bit more appropriate. So what I can do in that sense is I can either, do an offset mate by grabbing my mate tool and doing just a simple distance offset mate from maybe these internal faces here. However, I want to do something a little bit different because I want to make sure that this always remains perfectly centered over the top of, say, the worm shaft. So what I'm going to use is I'm going to use a different type of mate called a width mate to capture that kind of an intention. So the width mate can be found underneath your Advanced Mates tab over on the left, and you can see right below Symmetric we have width. Width is a really useful type of mate in which I can take a set of face selections, like maybe this face here and this face here, and I can space that evenly about another set of selections. So this other set of selections can either be two faces, so I can pick maybe this face here and this face here to space those evenly between them, or it can be a cylindrical selection, like this face here, okay, which will place this the axis of this cylinder right equidistant between these two faces that we selected here. This kind of suits our purposes nicely. Okay, so with this involved, we can click on OK. And you can see now when I click on this, I cannot drag this left and right. I can only spin it around on the screw. Okay, which makes sense so far. All right, so still our screw can slide in and out of the housing, but we do have this worm gear in here very nicely placed. So let's focus on the screw next. So the screw, I really don't want it to be able to pass in and out of the housing, and certainly as I animate this and add in gear mates and things like that, I don't want to allow for the screw to kind of pass in and out and fly away off into the distance. This is somewhat of a common problem that I've seen in people's assemblies in the past, is you'll run into a situation where with a lack of constraints in your assembly, you can end up with a model that flies way out into space, and it can cause a ton of problems in your assemblies. First of all, locating them, but also just for performance reasons. So what we're going to do is we're going to limit the movement of this using a different type of advanced mate. So I'll grab my mates command once again, here in selections we have in the box, and click on advanced mates. So what I want to do is I want to limit the motion of this, this screw within a certain bounds, but still allow for movement. Okay, so a distance mate isn't going to allow that to happen because a distance mate is purely a distance offset. So if I were to use a distance mate between this face and this face, it would remain that distance, and all of my motion would really be locked. Okay, so that's not really what I want to use in this situation. In this situation, what I'd rather use is this mate right here, a limit style mate. Ironically, even if you hover over it, it says distance, but don't be deceived. It is, in fact, a limit mate. And if you click on this, it acts very, very similarly to a distance mate, except it also gives you the functionality of defining exactly what bounds that this object can travel within. So between these two faces selections that I have here, I can say, well, at the normal position, this is 0, right? Coincident, effectively, okay, which is believable. And then at the maximum condition, this will be inches. Okay, whereas at the minimum, it can only go to 0 inches. Okay, so basically the lower region here sets the range. This can travel between 0 and 6 inches, and we're going to start off at 0 inches. So when I click on OK, we can try out this mate, and you can see that I can't drag this to the right anymore, but I can drag it to the left. to a length of 6 inches. It stops at 6 inches and will not allow this to travel any further. If we were to edit that mate once again, you can see that this dimension up here is in fact variable. So this dimension will change depending on the position of, say, these two faces with regards to one another. But they can only ever travel in between these two values, 0 inches and 6 inches. So I can constrain my model in that sense to still allow movement, but to stay within those two bounds. Okay, it's a really nice mate to use to capture motion like this, just linear motion while still constraining it properly. Now, one of the last things I have to do here is capture that gear ratio between the worm and the worm gear. Right now, both of them just kind of sit here spinning. So what I'm going to do is I'm going to actually turn on a sketch that I have in my worm gear for the pitch. So when you create gears or you model gears, you should always really create a sketch that details the pitch diameter of that gear. Okay, so rather than relying on the outer diameter of this or the inner diameter, you should really model a sketch. It's a very, very simple sketch. All it is a circular entity, circular sketch entity based around the center line of that gear with the pitch diameter in place. Okay, and the reason I'm going to model this is because when I mate to a gear inside of SolidWorks, I want to be mating to the pitch diameter and not necessarily to the teeth or any other geometry on that gear. So what I'm going to do is I'll go ahead and add in another type of mate inside of here. We're going to jump ahead beyond advanced mates and move into mechanical mates. So inside of mechanical mates, there are a bunch of really great mates that you can use to capture motion. The two or three, there's a few in here that we're going to focus on today, the first of which will be the gear mate. So I'll grab a gear mate here, and it'll allow me to select two selections. I can pick either a cylindrical face, which represents the pitch diameter, or I can pick a circular sketch entity, which would represent the diameter. Okay? And that would be all that I need. It'll pick up the gear ratio between the two properly. And as I spin one, the other one is going to spin appropriately. Now, I always recommend that people test this out to make sure that the movement is appropriate. And it appears here the movement is not. So as I spin this counterclockwise, or we'll say clockwise, this is moving in the incorrect fashion. Not a big deal. We can always come down here and click on reverse to flip this around so that it's moving in the correct direction. Okay. Now, it picks up the gear ratio automatically, but we can always key in our own. So if I wanted to, I can override the gear ratio that it derived from the two pitch diameters and key in my own. So maybe I know that this is in fact a 1:20 gear ratio. I could turn that on and again test the motion. Oh, no, that is still backwards. So we'll keep that there. Make sure that this is a bit more appropriate. Okay, so if you know the pitch diameter, you can model that in and mate that together, and that'll produce it'll produce the correct gear ratio right off the bat. But if you need to, you can always key it in to override the gear ratio to make sure that it is precise. Okay, so this is 1:20, so it looks pretty good. We'll click on OK to accept that mate, and then I'll just hide this pitch diameter for clarity. Okay, but you can see that we've created a really nice relationship between these two components in which, as the worm turns 20 times, we get one rotation out of our worm gear. Okay, it is a 10-ton jack after all, so it's going to be a really high gear ratio. So beyond that, now I would like to see this actually translate. So right now we just have our worm gear spinning, and the screw itself is just sitting in place. So we'll need another mate to allow this worm gear to actually act on the act on the screw itself. we'll come back into our mates, go back down to mechanical mates, and in this case, we're going to select the screw mate. So a screw mate is a special type of mate in the sense that it requires two cylindrical references, or even conical references, really. You can select either a conical reference, a cylindrical reference, or an axis. It does not care so much about your selections in so much as they are concentric. Okay, so a screw mate, it's kind of special because it not only creates a concentric mate between the two references, but it also allows you to specify things like the distance per revolution, or revolutions per distance. Okay? So if I key in something like, I know this one's meant to be about 0.17 inches per revolution. We apply that mate and test it out. As this revolves, you can see the screw itself is actually going to translate. All right, very, very nice. That looks pretty good. We'll click on OK to accept that. And now you can see, we'll test it out. If I turn our worm here, I'll say I think this direction is appropriate. It's a little hard to see. Maybe I'll change the gear ratio so you can see it a little bit easier. But as this worm spins, the worm gear turns accordingly, and the screw itself begins to translate. Okay, so it's some really cool relationships that we can build using these SolidWorks mates to build gear trains and relationships such as this one here. Okay, so this looks pretty nice. So what we're going to do next is I want to go ahead and show you one different type of mate that's outside of this gear train here. This is a new mate that they added very recently to SolidWorks 2014 called a slot mate. So if I wanted to add on a new component, the top face of this, so perhaps something like a V-block, I can drag and drop that on here and maybe rotate this into a position that makes a bit more sense. So once we have this in place, you can see I have some slots on my model face already. And let me go ahead and we'll just fix this guy temporarily. Let's see if that'll cause any problems. It will not. We'll just fix it so that it does not actually move anymore or translate anymore. So I can show you this. So we have this cylindrical face here to represent our mounting pins. And we have those fit inside slots on the face of the support plate at the end of the screw. So with this here, what I would really like to see is I want to make sure that this pin travels only within the confines of the slot. I don't want it to do something like this, which is not very natural. So what we'll do is we'll use a new type of mate that was recently introduced in SolidWorks 2014. Underneath the advanced heading here, we'll select, it's underneath the mechanical mates down here. We'll select a new type of mate called the slot mate. Slot mate is a very, very clever mate that allows you to simply select a cylindrical face as well as any face of a slot created using the slot feature. Say this face here. It picks up all of the adjoining faces of that slot and creates a relationship between the center line of this pin and the center line of the slot. So if I keep this set to free, we'll just say OK. You can see that this is only now going to travel within the confines of the slot and remain in place. So I can't drag this any further to the left here, right, or any further to the right. Right? I think it's pretty cool. And it's something that a lot of people have asked for in the past, is some very easy way of capturing the slot mate. It's something that used to be relatively difficult to capture in the past, so it's something that I'm very happy that they implemented into the software. Okay, so that looks pretty good. So all that's left to do now is I can go ahead and complete this adding maybe a couple additional components here, like a couple flange nuts to the end of this this model here. Now, one thing that I'd like to show as well, as it relates to mating that some people may not have seen before, is something called smart mates. So if I rotate this guy around real quick, just so it's easier to see, smart mates are a command that can be initialized using the Alt key on your keyboard. If you hold down the Alt key and click and drag a face, you'll see this small paperclip icon appear beside the right of your mouse cursor. Once this is activated, I can then hover over other references, like this shaft here, to automatically mate between them. So when I release, it creates that default concentric mate for me, and I can click OK to accept. Makes it really easy to add new mates to your design. Another thing that I can do is I can select two faces, like this face here and this face here. And this is something that is also relatively new. Well, it is new to 2014. If you select two references, say two planar references like this, you'll see this quick tip toolbar appears beside the right of your mouse cursor and allows you to apply mates on the fly. So previously, I would have had to go into the mate dialog and add mates the common way. But now I can click on coincident, and it applies that mate and accepts it automatically. All right? It's really quick and easy to use. It makes it all the faster to add mates to my assembly. So I can do the same thing over here. If you haven't seen it before, if you wanted to copy a component inside of an assembly, easiest way I found to do it is to hold down the control key and drag a component like this flange nut, and it's going to copy that and allow me to place this over here. So one other thing that I can do as it relates to mates, it's something called, where are we? Well, we'll do something else here. So let me go ahead and add this the same way. We'll hold down the Alt key, click and drag, add this to the shaft, and do the same thing with the internal faces here. Grab this face and this face, and add a coincident mate. Right? And that'll more or less complete our assembly. So I'll unfix this component so it can spin once again. Big float. And let's see if our assembly operates as we would expect it to. We'll rotate maybe around here. Rotate this around. And you know what? Let me change that gear mate so you can actually see the movement. Let's make this something like 1 to 5 to get more reasonable. As I rotate, you can see that as I spin the worm gear, or excuse me, spin the worm gear spins, translates the screw, and we actuate the jack upwards. Okay, and the reverse is true as well. Okay, and ultimately, if I were to click and drag this V block, you can see that it can only travel within the confines of the slot. Okay, so just by dragging this around, you can see that the movement is very, very realistic. Okay, I can't drag this inwards too far, and I can only drag the V block left and right. Now, one other aspect of the slot mate that you can also tap into is you can change this from just a free constraint, where I can drag this freely in space. You can also center this in the slot. So for purposes of mating this to other components in your assembly, or for the purpose of documenting this assembly with a drawing, you can simply say to center this in the slot, and it will constrain it to the center of the slot. Okay, it makes it a lot better if you want to do section views or anything like that of your assembly, because you're guaranteed that this will, in fact, be in the center of that slot. Okay, so our assembly looks pretty good. Okay, so far what we've touched on are a few advanced mates and mechanical mates to create this type of movement that you see in the animation beside the right side of the screen. The next thing that I want to talk about is a different type of assembly in which we'll talk about a couple other mating types, or a specific mate type that is similar to the slot mate, as well as getting into the SolidWorks animator. So what we have here on screen is an example of but hopefully you can see that, in fact, what we have here is an assembly of a packaging machine that's taking some snacks, some bagged snacks, and packaging them up into shipping boxes for delivery. Okay, so it's using suction to pick up those packages and place them inside of the boxes on the conveyor below. So I'm not quite sure what products these are on the conveyor, but I'm going to presume that there's something called SolidWorks snacks, geometrically delicious. So what we're going to focus on is an assembly that focuses on the packaging of these snacks into their respective boxes. So let's take a look at that assembly now, shall we? So we have our packaging machine here on screen, and we have the robotic arm attached to the frame up here, and that can be used to actuate and move to pick up these snacks on the right and lower them into the packaging below. Now, as it stands right now, the robotic arm is free to move any way that it would like. So as I click and drag this around, it can move anywhere on screen, not really being constrained by much of anything. So if I, in fact, had a specific path like the one that you see on screen here that I wanted this robotic arm to follow, I can form a relationship between this three-dimensional or two-dimensional sketch and the robotic arm using another type of mate called a path mate. So if I come into my mate dialog once again and go into advanced mates, I'm going to select a mate type called path. Inside of here, I can define a component vertex as well as a path selection. So the vertex in this case would be perhaps one corner of this robotic arm, and the path will be my sketch. And you can see as I make those selections, it attaches the robotic arm at that vertex to the path, and now as I drag the robotic arm along, it will only allow me to translate this robotic arm along that path. Okay, so you can really control specifically the path that you want your more free-form and free-to-move components in the assembly. Control how those are meant to actually move in three-dimensional space. Okay, constrain them in some way while still allowing for some pretty free-form movement inside of that range. Okay, so path mates are exceptionally useful for this, and they can be controlled in much the same way as that slot mate. Okay, so they have some similar controls here. I can either control this with a free motion where I can click and drag that anywhere I want, or I can control this using a distance along the path, or my favorite, a percentage along the path. Okay, so if we go by percentage, we could say 0% is way over here, and 100% would be over here. Okay, this is extremely useful if you want to define at specific times the position of this robotic arm. So maybe I do want this to be exactly 100% at this point. Right, but we'll leave this at free for now. Now what I'd like to show is this robotic arm coming down from this lower box here, coming up and attaching and suctioning these small pouches to the robotic arm. So a great way of doing that is using sets of mates. So underneath our mate folder down here, you can see I have that new path mate that I just added. But I also have some folders that I've used to categorize mates based on their function. So sometimes a set of mates can be, is used specifically to control a temporary position of a set of components. So say these 4 pouches that you see here on the conveyor. Right now, we have one set of mates simply controlling the position of these mates relative to one another. Okay, so they're all going to be coplanar on the bottom faces. They're going to be spaced by a particular amount between one another and things of that nature. So that one is going to stay active at all times. Whereas ones like this one here on conveyor simply link the pouches to the conveyor belt that they're sitting on. So I can have one folder here for that, but have another one which contains mates that attaches these to the robotic arm itself. Okay, right now these are all suppressed. So what I'm going to do is at the point in time where I want this to transition from the conveyor belt to the robotic arm, I can turn off the on-conveyor mates by right-clicking on the folder and saying suppress, and turn on the arm attach mates by right-clicking on that folder and selecting unsuppress. Okay, at this position, they look identical, but as I click and drag the arm now, you can see that those pouches are going to follow along with the arm's movement rather than sticking to the conveyor. So you can use this to your advantage by controlling it at specific times when you want the first folder to be active, say over here, and when you want the next one to be active. Okay? This can be greatly used to your advantage when we get into animations, like I'd like to show you now. So if we take a look at animations inside of SolidWorks, you can activate the animator by clicking on this animation tab down here in the bottom left-hand corner of your screen. What this is going to do is open up your animator, and it'll allow you to specify exactly how components move relative to time. So if we click and move through this animation that I have here, you can see that I have some of that motion that I was speaking about earlier. The robotic arm, let's see if I can zoom in, I'm not sure if I can. Here we are, so the robotic arm here is going to come in, pick up those pouches, and drop them into the box below. Okay, and that box is going to move on down the line. Okay, so the way that I captured this was not only using the path mate that I have here, but using that percentage along path specifically. So a big component of creating animations inside of a SolidWorks assembly is really leveraging the power of SolidWorks mates. So, certainly you're going to have movement within the assembly itself, and you can capture that simply by dragging this time bar, say 0 seconds, capturing the initial position of these components, drag this to a different time, and select a different position for those components, just by dragging them on screen or moving them any way you'd like. In this case, I made use of the path mate that we selected earlier. So if I scroll down here on the left, you can see the mates folder is opened up, and inside of there, I have some of those path mates that I added, say path mate 3. So at the 0 position, and if we double click on this node here, you can see more clearly, at the 0 position, or 0 second position, the path mate is at 0%. And when I move to, up a little bit here, and when I move to the 2 second mark, that path mate changes to 100%. So the way that I would create this inside of SolidWorks Animator is by first defining that, drag the timer bar over here. I would define this by double-clicking on it, keying in 0% for the timestamp there. That would create a key, and then I would drag this time bar over here, right-click and say Add Key, which you would see if there was not a key there. Okay, so place key. I would get a new key there and double-click on this and say that this is now 100%. Once I calculated the animation, I'd end up with the motion that you see above, right? Where over the course of 2 seconds, my robotic arm is going to travel from 0 to 100% along that path mate. Okay? Now between there, between 2 seconds and about 2.5 seconds, I also made use of the on conveyor and arm attach mates that I showed you earlier. So the reason that I separated these out into multiple folders and basically grouped folders is that it makes it very easy that at particular times I can activate one. Maybe it's a little easier to see if I expand these out. Yes, it is. I take one set and activate them. The initial portion of this animation from 0 to 2 seconds. On conveyor is active during that position. And then once it gets to the very end, on conveyor turns off and arm attach turns on. It's kind of a tricky way of showing behind the scenes, or controlling behind the scenes how these pouches should move. Okay, because the viewer of the resultant video is not going to see the mates attach and unattach, but you can use these to your advantage to control them inside of SolidWorks. Then once they get over here, I have them change from being attached to the arm, like they are now, being the box. Okay, so that'll drop those into the box down below. And then I use the animator and another path mate for the box to allow that box to continue traveling on down the line. Okay, so using this animator, you can create some really nice looking animations by selecting Save to save that animation out. Now, if you do click on Save, one thing that I'll point out is in addition to setting the resolution of the resultant animation, you'll also have things over here for frames per second. Now, just like movies and videos, I'd recommend a higher frames per second over the default of about 7.5, just because at 7.5 everything's a little bit jerky. Ideally, you're going to want probably between 20 and 30 frames per second, 30 being ideal, 60 being outright ideal, but 30 is kind of the minimum to get a really nice smooth animation that you can't notice the jerkiness so much. However, keep in mind that the more frames per second that you add, the larger the file size will be. Okay, so if you're just trying to get a very simple point across, 7.5 seconds should be sufficient. If you're trying to create something that's a bit more customer-facing or that you would like to put on your website, I would recommend using something like 30 frames per second so that it's nice and smooth and easy to view. When you click on Save, you're going to receive this page here for video compression. To create the smoothest animation, again, you're going to want to increase the compression quality all the way up, and you'll want to turn off keyframes by clicking on this option here. Again, both of these options are going to drastically increase the file size, so you'll have to play with the options a little bit to weigh the difference between having a high-quality video and a very large file size, or having a lesser quality video and a smaller file size. Okay, but for if you're just interested in quality, I always recommend that people turn off keyframes because keyframes are going to introduce a little bit of jerkiness into the video. Okay, but once you've saved that out, it will go through, it'll play through this animation and save it out, and you'll end up with a very nice looking animation, something like this. Okay, so this packaging machine here. Okay, so where we can save out this animation, we'll create an animation like this where the packaging picks up those pouches and drops them in the box and sends that box on down the line. All right, so it's pretty cool. It's a great way of capturing this kind of motion inside of your assemblies and reusing it to create other types of content like animations and images. SolidWorks snacks. Okay, so we've spoken about the SolidWorks animator and just kind of touched on how you can use another type of mate, an advanced mate called a path mate, to control the motion of your assemblies, as well as how to take all of that together and use the SolidWorks animator to create some really nice looking animations for your assemblies that you can reuse over and over. So I just want to thank everybody for attending this this demonstration here today. My name again is Timothy Pulaski. My contact information is on the page here. So if you guys have any questions or comments on this presentation or otherwise, feel free to give me a call or shoot me an email, and I'd be happy to respond. Again, thank you very much for attending.